Okay, let us now look at how to use the built-in function in your calculator to achieve the same results. Okay, remember we were given rectangular coordinates, which means that we have a rectangular coordinate, I call it R, rectangular coordinate. We want to convert that to polar coordinate, meaning that we want to find the distance as well as the bearing. So on your calculator, I've got an FX 570 Casio calculator. You probably have a different model, but the functions are in there, so you have to explore a little. Okay, if you look at the video now, okay, just bear in mind that number there. There's a difference in this thing. Sorry, that difference in northing, and there's a difference in easting. So if you look at the calculator, your calculator, you'll find that the plus and minus button, there's a function written. The second function is REC for the minus and POL for the plus button. So REC simply stands for rectangular and P stands for polar. So what we're going to do now, we're going to convert rectangular to polar. Okay, so you clear everything up, press shift. Now those two buttons I was mentioning about. So you need our pole now, because you can convert rectangular to polar. You key in the difference in northing first. Okay, so like so, 83.325. Then followed by a comma. Then you key in your difference in easting. Then you close the bracket. When you press equal, that will give you the distance, and that will give you the bearing. Okay, all right, so that's basically what we want. Okay, we're going to repeat that. Key in this difference in northing, then key in the difference in easting, close that. Then the first answer, the first value that you obtain will be your distance. Okay, so that's your distance, 83.598. And now if you press RCL and tangent, that will give you your bearing, 524.54. You've got to press shift to get the numbers in degree, minute, and second. Okay, so that's how you go about calculating or using the functions in your calculator. So I recommend that you use that function, because it will give you the right answer, the answer in the proper quadrant. You don't have to worry about whether it's negative or positive. Just put in the differences as what you have calculated. Okay, so let's now discuss a little bit on errors. Okay, let's talk about errors in the traversing, because we know that this is the one thing that we cannot run away from, errors. We have to be able to understand what are the errors, and we must have this ability or procedure or method that we can apply or employ to minimize or perhaps to eliminate the errors if we can. Okay, so up to now, we've talked about collimation error. Okay, so that's basically systematic error, and it can be corrected. Okay, if we just observe in both phases, highly likely the collimation error will be eliminated. Okay, and assuming that there's no gross errors in our work, we've put away, we have taken care of the systematic error, and there's no gross error. We've checked, there's no gross error, everything seems to be okay. So whatever remains will be the random error. So this random error will result in some what we call as traverse misclosures. Okay, bound to be error, and normally they are quite small, and we can do something about it. Okay, so we're going to look at the procedures and methods of how to treat these errors and how to distribute them. Okay, similar to what we did in leveling. Okay, distribution of random errors. Okay, I've got an example there, just simple triangle. Yeah, a 3, 4, 5 triangle. So assuming that I measured 3, 4, 5 exactly, and I measured the angles as per shown exactly, so everything works out. Perfect triangle. You add up all the angles inside, they're all 180 degrees. So there's no problem with that. So that's error free, and which I think in real life is quite impossible to achieve. You might be 1 in a million probably, but in normal circumstances, something which is you don't expect to happen. Okay, so before we could go further on error treatment or error analysis, let's sit back and think about it. What do we measure in a traverse? What are the things that we measure? We measure angles, we measure distances. So therefore, random errors in these two measurements are unavoidable. We cannot avoid them. Okay? And we have to know how to deal with them so that the effects to our final answers will be minimized. Okay, now
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.